Hello. In this video, I would like to share a technique that can be used to solve a triangle for missing side lengths and angle measures. While simple trigonometric functions can be used to solve right triangles, non-right or oblique triangles require a little more work. For the purposes of this lesson, we will use capital letters to represent angles and their measures. We will use lowercase letters to represent sides and their lengths. When solving oblique triangles, we must be given at least 3 of the 6 measurements, one of which must be a side length. The law of sines cannot be used to solve every oblique triangle. In fact, it may only be used in the following 2 cases. There are 2 scenarios in the first case, both of which involve 2 angles. The acronym ASA stands for angle, side, angle, and it indicates the 3 provided measurements are 2 angle measures and an included side. An included side is one that is between and connected to both of the provided angle measures. The triangle on the left here is an example of an ASA triangle. The 2 angles are provided, and the known side length is directly in between. In the second scenario of the first case, the acronym AAS stands for angle, angle, side, and it describes triangles where 2 angle measures are supplied along with an excluded side length, one that is not between the supplied angles. The second case for which the law of sines applies uses the acronym SSA, which stands for side, side, angle. In this case, 2 side lengths and an excluded angle are provided. This case is sometimes called the ambiguous case, since it is possible to find more than one solution to the provided information in some SSA triangles. Usually, when a diagram is provided, only one solution exists. We will not see an ambiguous solution in this video. The triangle in the middle illustrates a non-ambiguous SSA case. You should notice that 2 side lengths are provided, and the angle measure of 80 degrees is not directly in between. Please pause the video now and determine which case is illustrated by the third triangle. Resume playback in a moment to check your work. With 2 angle measures provided and a side length directly in between, this is an example of the ASA case. The law of sines states the side lengths of the sides of a triangle are proportional to the sines of the corresponding opposite angles, which is usually accompanied by the following equations. Let's use this information now to solve the first triangle above. Since our objective is to identify all side lengths and angle measures, I like to start by writing down the provided information. In this example, it is very easy to solve for the missing angle measure, so I'll do that now. Now that I have an angle measure and a side length referencing the same letter, the law of sines becomes very helpful. I will create a proportion using sine of angle measure C and side length C, along with sine of angle measure A and side length A. Since cross products are equal in proportions, we can use simple algebra to isolate the variable a. And now we can enter this expression into a calculator, making sure it is set to degrees, and solve. In a very similar way, we can solve for side length b. In fact, I would recommend using angle measure C and side length C again, since we needed to round the result for side length A. Using a rounded result would reduce the accuracy of future calculations. And now we have side length B, therefore the triangle is solved. You should notice that the smallest angle measure corresponds to the smallest side length, and vice versa. This will always be true for triangles and is a quick way to check whether your answers seem reasonable. Using the law of sines in the second example is a bit more tricky. Here you see the side length A and angle measure A are provided, which will be needed to compute the missing angle measure B or C. Then, with that calculated result, we could solve for the third angle and then the missing side. Please pause the video now and try this on your own. Resume playback in a moment to check your work. The use of arcsine was necessary to solve for angle B. However, once it was calculated, we could use the same techniques as before to solve for the unknown angle measure C and side length C. By practicing with the law of sines, it is possible to discover shortcuts and extensions to the law. One such extension is used to compute the area of a triangle, even if the altitude or perpendicular height is unknown. All that is needed are two side lengths and an included angle measure. Since we have already solved these two triangles, I will use the results from before to compute the area of each using the first form of the area formula. For extra practice, I encourage you to compute the area of each triangle again using different values from each triangle and a different form of the area formula. Good luck.